This is the next point, architecture of 8086 microprocessor or block diagram of 8086. Processor is a 16-bit processor. That is, a diagram shows the block diagram of 8086. It is, the CPU is divided into two part. That is, a two part are BIU, and that is, the CPU is divided into two independent functional part. That is a bus interface unit, and execution unit. That is a bus interface unit. This is the architecture or block diagram. That first part is BIU, and that is the independent CPU is divided into two parts. That BIU, bus interface unit, and another part is that execution unit. That BIU sends that function of BIU dividing the work between these two units. That processor speeds the microprocessor. That speed the microprocessor processing. So BIU first is bus interface unit. That functions of that BIU sends out the addresses, fetches the instruction from the memory, and reads the data from the ports and memory, and that ports input and output port, and from memory, and writes the data to port, that port input and output port or memory. That is the function of that BIU. That BIU sends out the addresses, fetches the instruction from memory, and data read from the memory or IO devices, and data write to on memory or IO devices. That is the function of BIU. And other word, that is the BIU handles all the transfer of data and addresses on the bus for the execution unit. That bus interface unit is responsible to perform the all bus related operations, that including transferring address on address line, receiving data from the data line, and generating the control signals. That BIU consists of that first is that diagram BIU. Bus consists of B bus, that consists of segment register, and segment registers are segment register, instruction pointer, and instruction queue. These three blocks are in a BIU. And EU, in EU there are the different parts. We study today BIU. That BIU consists of 16-bit segment register, ES, CS, SS, DS, and 16-bit instruction pointer, and address generator unit, that is a 6-bit register in a IQ, that is the instruction queue. That instruction queue is a 6 byte long. In this BIU there is one question asked, what is the function of BIU? Which blocks are in a BIU? In a BIU there is a 16-bit register. There are the 16-bit registers, instruction pointer, and a instruction queue. First is the segment register. There are the segment register. There are the 4 segment registers, 16-bit each. That first is a code segment. This code segment register is used for addressing of a memory location in the code segment memory. In the code segment memory there is a code segment register CS. CS is a memory. In that CS memory there is a CS register. In a data segment memory, DS memory, there is a data segment register, that is a DS register. That is memory is a 64 byte, but in that memory there are the register, that registers are a 16 bit, that register are 16 bit. And that in that memory, code segment memory, that CS register is used for addressing of memory location, addressing of memory's location in a code segment memory, where the executable program is stored, where the executable program is stored. That is a function of code segment memory. Data segment memory, a data segment register, that data segment register is used, that register points the data segment of memory, points the data segment of memory where the data is stored, where data is stored. Next, stack segment. This stack segment is used for the addressing of stack segment of memory, stack segment of memory, which is used to store the stack data, which is used to store the stack data. And next is extra segment. Extra segment, which is essentially another data segment of memory, and that extra segment is also referred to segment, which is another data segment of memory. This extra segment memory is used to store the data and result. In a CS register, we store the executable program. In a data segment register, we store the data. In a stack segment, which we store the stack data, and in extra segment memory, we use to store the data and result. We store the data and result. This is the segment register in BIU. Next is the instruction pointer, that is a IP. That IP is a 16 bit. That IP is a 16 bit. The instruction pointer register holds the 16 bit address of next code byte within the code set. And in this IP, there is a value is stored of the offset, or in this value is stored, that value is called as offset or displacement. And this instruction pointer holds the 16 bit address of next code byte within the code segment, And next is a IQ, instruction queue. This instruction queue increases the execution speed, and BIU fetches as many as 6 instruction bytes ahead to time from memory, and that all 6 byte registers are then held in a first out FIFO manner, and that 6 byte register is called as a instruction queue, and that then all bytes have to be given to the EU. That form, that one arrow is for EU, form the instruction queue, that all bytes have to give the EU. Then how speeds up that Q speeds up the processor, that 80X is when BIU fetches the instruction bytes, EU executes previously decoded instruction. EU executes the previously decoded instruction, and so it is quite fast than sending out an address to memory and waiting for memory to send back to the next instruction byte. So Q, that is instruction queue, speeds up the program execution. Means that bus interface unit fetches the 6 instruction byte ahead the time from memory, and that pre-fetched instruction bytes are held in a execution unit in a first in first out manner. That group of instruction is called as a queue. Means BIU fetches the instruction byte, EU executes the previously decoded instruction. So there is a quite fast than sending out address to the memory and waiting out back to the next instruction. In this way, there is a queue speeds up the processor. This is the function of BIU. That in a BIU there are the segment register, instruction queue. Segment register are 4, instruction queue this is a 16-bit register, and the instruction queue. Ask what is the function of BIU, which blocks in a BIU, and another question is asked what is a queue, how does queue speeds up the processor, Next lecture we study the EU part.